In this lesson, we will use the Wireshark utility to assess organizational security. We are in the Wireshark portion of the video series. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the exam. So what is Wireshark? Wireshark is a powerful tool for analyzing network traffic. Network administrators, cybersecurity professionals, and IT analysts use Wireshark to monitor and troubleshoot network activity. It is typically used when you need to diagnose issues, analyze traffic, or ensure everything is running smoothly on your network. Wireshark is used when analyzing network issues, detecting security threats, or performing forensic investigations. Wireshark is essential for diagnosing network issues, detecting cyber threats, and optimizing network performance. To use Wireshark, run Wireshark for the GUI or T-Shark with your Ethernet interface in the terminal or command line packet analysis. The rest of the how is what this video is all about, so let's get into it. But before we do, we have a few important topics to discuss. The legality of Wireshark depends on where, how, and why it is used. There are some legal use cases. For example, capturing traffic on your own network for troubleshooting, or using Wireshark for educational or lab environments with proper authorization, or monitoring networks when explicitly authorized. However, there are some also potential illegal use cases too. Capturing packets on a network you don't own or have permission could be potentially illegal. Intercepting passwords, private messages, or sensitive data can also be potentially illegal. Or using Wireshark for hacking, eavesdropping, or surveillance could be potentially illegal too. Now, many countries have cybersecurity laws. For example, there's the US Wiretap Act. The General Data Protection Regulation, GDPR, is a European law that protects the privacy of personal data. We also have the CISA, which is the Cybersecurity and Infrastructure Security Agency regulatory guidance that prohibit unauthorized network monitoring. Always obtain explicit permission before capturing traffic. So here are some ethical guidelines. Respect privacy. Avoid capturing sensitive user data unless required for troubleshooting and with consent. Follow organizational policies. Companies that may have strict policies on network monitoring, make sure you get written approval before capturing data. Use in controlled environments. For example, for training or use in lab environments instead of production networks, like what we have here in CyberLabs 007. Also, only capture what's necessary. Minimize data collection and avoid storing unnecessary sensitive information. And then last but not least, educate and inform. Each one teach one. If you're using Wireshark in a teaching environment, emphasize the legal, ethical usage. With that said, let's kick things off. To get started, grab the companion guide from the link in the show notes below. Also, if you like this content, please make sure to subscribe to the channel so you won't miss any new videos. So we're all set. We have our companion guide. We have companion guide on the left. We have Ubuntu Linux on the right. And sitting behind here, just really quietly, we also have our Kali Linux. And that's going to be part of our network here. And we'll explain this as we get into it. So let's reset and let's go ahead and launch a terminal session on the Ubuntu side. So we'll open in terminal. That'll put us into the desktop. We'll enlarge this for a bit. And also, I'm just going to make the screen just a little bit bigger and give us a little bit more real estate. I think we look pretty good here. So we're going to install Wireshark onto Ubuntu. Now, the assumption is, let me just get this going while I speak. Sudo apt update. Yes, I can combine the commands. So let's just get the password in. I can combine the commands, as you see here, with the ampersand just to get it connected. So if you want to, you can throw the whole command in. It's going to look at available update packages. And then the next step is that it's going to install Wireshark and -y to accept any prompts that's going to ask us, do we agree? So let's wait for this to continue. So that took about 10 seconds. So I'm ready for the next set of commands. So I'm going to do sudo apt install. So we just do the install and we're going to do Wireshark. And once again, the reason why I do this here is that if you use Kali Linux, and that took only a second because it was already installed, As you can see here, Wireshark is already installed and it's at the newest version. So I'm going to go here to clear it. And yes, Wireshark is already pre-built and pre-installed on Kali Linux, but if you're building this from scratch is why I like to just show how you install it if you're not familiar on the installation, and also this quick configuration here. So what we're doing here is, first let's go this in reverse. Let's go to the groups command to see all the groups that I'm a member of. Obviously I'm in my fmerin group. There's also the Wireshark group, which means I do not have to run sudo when I launch it from the command line. But if you're not sure how to do that, you can just go ahead and install, make you a user mod. So user modification sudo, we're going to add to the group Wireshark the current user. And that's what's going to add us to the Wireshark. You usually have to log out, log in to do that, but this sets the stage so that way you can just run Wireshark from the command line if you want to. Okay, so let's do some housekeeping. And let's go ahead and take a look at our interface, make sure our interfaces are all set and ready to go. So I have ifconfig to see if I have this interface, which is the Echo November Papa 0 Sierra 3. This is the IP address and this is the MAC address. So just to be sure, I have the Ubuntu machine sitting at 102, 176.16.1.102, and also this is its MAC address. 1 Charlie Alpha 9er. Okay, great. So this looks fantastic. I don't need to pull a new IP, and I can just go right into sudo Wireshark. In this case here, I'm going to just run it from the command line without the sudo, and it's going to come in. And let's give that a second to fire up. And I can do it from the command line. I also want to close out of this. I'm going to File, Quit, and also show you how you can run it because it's a regular application. For starters, I'll clear the command line and we can just go right into the activity screen and start searching applications here in the search bar, and Wireshark is available via the same GUI interface. Okay, so here we have it. Let me just give myself a little bit more room here. Okay, great. So we have the welcome screen. This is the welcome screen. And we have a couple of options. So the first thing is we're going to capture some traffic, and that way we'll be able to see. So I'm going to capture, I go to options, and I'm going to capture on the interface that we just saw in ifconfig. And we want to capture on the 172.16.1.102 and this Ethernet address. So I went here, I didn't do it from the command line, we didn't have to identify the interface, and I'm going to capture some traffic and hit start. There were other ways of doing this and we'll take a look at it. And now I'm capturing some traffic. What does that mean? This is like a video recorder of all the traffic that I'm privy to hear on the network. In other words, this card is listening to any hosts or nodes that are on this private network, the PrivNet. We only have 2 hosts. If we had multiple hosts, we can hear and the traffic, i.e. hear, see, and record, and the conversations they have with other devices. So right now it's capturing, but let's go in and make sure we have start. I know we have start because the stop button is enabled, and we'll let it run for a few minutes while we do some activities to generate some traffic. So let's go back to the command line and let's go ahead and just do ifconfig again just to make sure that our interface looks right. And we're going to do some basic ping commands. So I'm going to ping. I'm going to do a ping count of -3 just to keep it simple. So we go ping -C for the count, 3 packets, and let's go ahead and just do 176. Let's do the router first. Let's do 172.16.1.1. So we have Internet Control Message Protocol. We made an echo request. We received an echo reply, echo request, and we have 3 packets transmitted, 0 packet loss. So everything looks healthy on that side. Let's go ahead and do some more. We have our network here. So from the Ubuntu box 1.1.2, we pinged the interface. We went through this switch. Let's ping a couple of other devices. So I'm going to up arrow. Let's go ahead and ping ourselves 102. The local loopback, if you will. not specifically because that would have been 127.0.01, but we know this interface is up and running. We'll also go ahead and ping the Kali Linux. It's sitting on 172.16.1.103. We'll send 3 packets there, see what that looks like. Okay, we're getting echo replies. I'll clear the screen to get back on top. And let's see if we can ping the outside world. So we're going to ping Cloudflare. So we have 1.1.1. That looks good. I'll Control C to stop. And let's just go ahead and make sure we can get to another host. We'll do Google's DNS. And that looks fine as well. So we generated a fair amount of Internet Control Message Protocol. So we'll stop here. And we know we have connectivity between these 2 hosts. We can hit the interface of this router, go through that interface, the wide area network, and connect to hosts outside of our network. Okay, so let's do a little housekeeping. We did the if config, the pings. Let's go ahead and create some SSH traffic. Let's connect to the Kali Linux box. So I'm going to clear on this side, SSH, Kali at its IP address, 172.16.1.103. It's asked for the Kali password, and I am in. I know I am in because the prompt changes, but I also can do a host name. So I can do a host name, and I am at the Kali session or the Kali host name. Okay, great. I'm going to Control D to close that connection properly. In other words, send a FIN packet. I am back at the Ubuntu side, and if I do host name here, I'm back at the Ubuntu side. So that looks good. Let's generate some DNS traffic. We'll do clear. I'll do a NS lookup. So let's just do an NS lookup. And I can do the type, but I'm just going to do google.com. Just do an NS lookup, google.com. I get the IP address that I'm looking for. This is Google's, this was the DNS server, but now I know what IP address that Google has. If I was to put this into a URL, we have a whole video on that. We know how NS lookup looks like, so that's fine. And now I'm going to Firefox, and I just want to browse some HTTP traffic. And we'll go ahead and see what that looks like. Give it a moment. Firefox sometimes takes a little while to fire up. No pun intended. Okay, so this took about 10 seconds. Let's go ahead. Let's go to pfSense. I'm going to go to pfSense.org, generate some traffic here. This is the open source security platform. We take a look at some of the products to generate some more traffic. We can protect our network. And I think our job is done here from generating traffic. So we'll do our NS lookup, and let's stop the capture so we can examine this in Wireshark. So we're going to stop. And I'm no longer recording is essentially what I'm saying here. And just for fun, we're going to save this packet capture or save this recording. So we had the recording button on, we saved it, but all of it is in clipboard or in memory. Let's save this to a file. So the first thing is File, Save, and we have different captures. I'm going to call this my third capture of the day. Third capture. You can call it whatever you like. The important piece is that it is going to have the PCAP-NG file. It'll be applied automatically, and I have my file, and this portion is done. So let's take a tour of Wireshark. So first and foremost, you saw this portion here where we have the menu bar. The menu bar is going to give us some quick actions here. This is where we saved. This is where we started the capture. If we wanted to, there's another option here. We can click the gear icon. It takes us to the same place. And we have a number of options here on the menu bar. The toolbar are same actions here, but a little quicker. For example, this portion here, which we'll see, are all the packets that are happening. If I want to get to the beginning of it, I hit this back button or go to the first packet. And if I go in towards the end, I can go to the last packet, and I see we've captured in that small short session, it was 5,504. So 5,400 packets were captured in that short period of time. Speaking of time, we have our time setup here. We'll go back to the top. We can do a couple of different type of things in our setup here. So we have the full screen here. We can turn on different portions of the menu here, but we also look at the time display format. And I want it in date and time. We could do it by year, so that year is first. In this portion here, we want it time display with the date and time. And there were other options that you can play with, but the first one that I wanted to look at is go to the first packet, go to the last packet. If I'm at the first packet, I can step through one packet at a time, and this is the conversation as it's coming in. So we have this option as well. And we also can color code this based on types of traffic. So this is going to give us different coloring rules based on the type of traffic. For example, TCP will be colored a certain way, so on and so forth. And then we can look at particularly red. When something is jarring out at us, here it'll pop out because we're applying the coloring rules. So, okay, so we'll revisit this. Going back to the first packet, the time, we have the packet list pane. This is the list of all the packets. Again, we captured a total of 5,504 packets. All look clean, 100%. We drop 0, and we're on the default profile. So there's some information here that's helpful to us. So we have the time, we have the source IP, the destination IP, the protocol, the length of the packet, and a little bit of information about it, or details, if you will. So this gives us a very high level here. So this is the packet list pane, this area here. If we go into the packet details pane, it's going to show us detail information about a selected packet. More specifically, I have ICMP selected. This will give me a sense of how it's mapping or coming through the OSI layer. So let's go take a look at our network. So this is what our network looks like. Let's throw the OSI layer on top of it, which is the frame is the physical wire. So this is layer 1. Then we go to the data link layer where we have our MAC address. In this case here, this is 1C alpha 9. So this is the capture of MAC address, and this is layer 2 if we're taking a look at it this way. Then we get to layer 3, which is internet protocol. This has the source IP and the destination IP. It's mapping here. And then we get to the transport layer, which is in this case here, it's the internet control message protocol. We'll see this a little bit later, but we can expand this to get a little bit more information. But this is the packet details menu. Okay, so let's go ahead and tick off some of these and continue. We can also come down to the packet bytes pane. And this is where we're going to look at the raw packet in hexadecimal and ASCII. So we have it in ASCII format here, hexadecimal here, and this is if you need it for low-level inspection of packets. Generally speaking, we're not going to dive too deep into this, and this again is a high-level video just to give us an overview of Wireshark. Okay, so we have a quick overview of our files here. So we have the apply the display filter, we have the menu bar, we have the file menu here, the toolbar here, we have the menu bar, we have the packet list pane, we have the packet details pane, the packet bytes pane, and we have a few status bar down here. Let's go ahead and analyze the traffic by applying a few filters. So we know we have some ICMP traffic. This is filtering strictly by Internet Control Message Protocol traffic, and we know that we generated ping traffic from the Ubuntu machine 102 to the router, the pfSense router 172.16.1.1. Here's all that traffic that we could see here, and we get the length. All of this is recorded now that we have a record of that activity that we did earlier in the terminal command. And we see the echo request and the echo reply, echo request, echo reply, and we can track this packet by packet and analyze it. So this took me all the way down. I wanted to do it one at a time. So this takes me one at a time. If I want to jump to a packet, I can go ahead and go to a specified packet. Let's say we wanted to go to packet number 100. We can do that because we're working with someone and they say the packet you're interested in is packet 100 and it didn't have one. So let's make it packet 30. So let's say we want to go to packet 30. Obviously I could just click on it. I can go to the packet, but if you have, in our case, 5,504, we're only displaying 40 of those, we'd be able to go to a specific packet number. Okay, great. So that's ICMP traffic. Let's filter by TCP. We only want to see TCP packet, so traffic. So we go ahead here and TCP, and we have the TCP packet that we can take a look. And what's interesting here with this particular one, I'm going to the back side of this here, we can actually see the three-way handshake, and we'll see this again. So the three-way handshake, when this was making a connection on port 22, this is the SSH connection, we see that three-way handshake. So as you may remember, or if you haven't studied this yet, when TCP is making a connection, the first thing that it does is it sends a SYN packet. This is a request to synchronize to a client. So the client is making a request to the server in this case here. So here we have that SYN packet that's corresponding. Now the server is going to send a SYN-ACK packet, which is, I acknowledge your request to synchronize, and I have a synchronization packet of my own, and it sends it back to the client. Then eventually the client is going to send an ACK packet, an acknowledgement packet, and we call that the three-way TCP three-way handshake. You can actually track that packet for packet in this setup here. So we have it here, and right here we can just step through one packet at a time and see SYN, SYN-ACK, ACK. So that's one of the things that you can do with TCP. We can also filter by UDP. So you're getting the idea here. We can go and see the DNS traffic that we were looking for, and we also did an NS lookup. So the NS lookup that we did in the steps here when we were generating traffic, we can see that we ran NS lookup, and in NS lookup we were looking for Google, and we can see that Google responded and it gave us the 142. We can go ahead and do the packet details and get a little bit more information about that. So in the frame, this is it coming off the wire, that packet. It was at layer 2 at this part here where we get to see the Ethernet address or the MAC address, and it's coming off of Alpha 9. Let's go ahead and see which one was Alpha 9. Yes, this is the Ubuntu machine. We see the source, the destination, MAC address. We go up a little higher onto the OSI model, and we get to see the IP address that are involved in here. And then finally we get into the UDP, and it tells us it's port 53. And if you remember, if we look at port 53 is DNS. So we have true packet visibility. So this is essentially packet inspection, and we're using it on this protocol with the DNS. So let's go ahead and mark this off. So we can look at protocols, as you see, and also let's look at SSH. We can either do port number or by protocol, and we see that we can filter by protocol, and all these packets are encrypted, which means that we really can't see the details of that packet. Later on in the video, we'll look at telnet packet, and you see that telnet is in the clear. We'll be able to see the password authentication, and we'll also see the login credentials and the commands that were pressed in SSH, which is why it's recommended that we use that port 22. We cannot see that. However, we do have the recording of that event. Let's see what we have in HTTP. So we can also do HTTP as well. So let's go take a look at the protocols. We're looking for HTTP traffic, and let's see if we have any HTTP traffic. And yes, we see the certificate request to make sure if the certificates are valid. This is when we visited pfSense. And we can go filter a little bit more, either by packets, or we can filter by port. And then last but not least, let's go ahead and take a look at the conversation between the server. So I'm going to copy this here. I can build it in, of course. I'm just going to save some typing space here. Let me just get this guy out of the way, the terminal, and then we'll go back to Wireshark here. So we don't want that here. We want HTTP. I'm going to back this out and actually just paste and change the IP address. So back to our diagram. We know that we have 102, and I just want to, let's just say, look at traffic from the Ubuntu machine and the Kali Linux machine. And I'm just going to put a filter of only source to destination. Okay, this will give us all the packets that we have captured. We can go to the beginning packet, first packet, and we can see all of the conversations that were happening between these two devices, source IP to destination IP. So we can also go ahead and let's just do this to the router. Let's see what happens with the router. So we see all the source information that's happening between those. And of course, there's some information coming back for different reasons, which is we had a ping request working as well. So this is another way that we can filter some traffic. Okay, great. Let's move on down to following a stream. So I'm going to take a look at SSH again. So let's do SSH. Yeah, that'll work. Let's go through SSH. And as you know, it's secure shell. And we're going to take a look at one of those packets. And let's see if we can see anything interesting on it. HTTP could work as well. So I'm going to follow a TCP stream. I'm going to right click on a packet, follow, and see the whole stream. And as you can see, most of this is encrypted. It's not giving us a whole lot of information here. However, we can do some packet details as well, right? So we view the packet details. We can see the source, destination IPs, ports, and payloads. We can analyze the traffic distribution. So let's go ahead into statistics and look at conversations. And we see the conversations that are happening on our network. So this here is back to our diagram. When we go to the conversations, we're seeing the conversations that are happening on the PrivNet, the private network, using Wireshark. Once again, a very powerful utility in terms of network reconnaissance, eavesdropping, and optimization, and the list goes on. So we're at the statistics conversations. I can see Ethernet conversations, which is the MAC address. Speaking to MAC addresses, I can look at IPv4 packets. We can sort this by bytes to see which ones are having the most conversations. And then we could see the different traffic flows and what directions are the packets going in. And we can continue with IPv6, not a lot of activity. We could look at TCP packets versus UDP packets, and that'll give us another look. So this is host communications. We can also do protocol hierarchy. So we'll go to statistics, protocol hierarchy, and it'll give us a sense in this particular case here for SSH, which is what we were streaming. We had 82 total packets associated with this. 46 of them were SSH for a total of 56 percentage points. So this gives you really a lot of the raw numbers. But let's go ahead and look at TCP port 80 again, just to see that filtering. So we can filter by TCP port 80. I'll get rid of this so you can see that. Get rid of the terminal. So this one can just get out of our way, back to Wireshark. And we see TCP port 80. And once again, we see the three-way handshake with this particular server here. SYN, SYNAC, ACSYN. Okay, so let's go ahead and do a little work on the Kali side. We're going to actually do a simulate network events. We're going to run a stealth scan on Kali to Ubuntu. In other words, we're going to do a three-way handshake. We're going to do a stealth SYN scan. We want to see if a port is available. So I'm going to move over to the Kali side, and we have it tucked over here. So let's get the Kali Linux box over on that side here. And we're going to authenticate. And I'm going to open up a terminal here. So I'll open up a terminal, and I'm going to run an nmap. And in this case here, we're going to start a new scan. So in this case here, I'll show you a number of ways we could do this here. Right on the gear, I can start a scan. I want to make sure I have the right address. So this is the Ethernet card or the ifconfig that we saw. We're going to hit start. And I'm going to do TCP port 22. Let's just see what happens on TCP port 22. So that's what we're listening on. We'll go back to the Kali Linux, and we're going to make this one a little bit bigger. 1, 2. And let's go ahead and take this nmap command, and let's break this down. So this is a stealth SYN. In other words, we're only going to send a SYN packet. We're not going to send the acknowledgement packet on ports 22, port 80, 443, and the target is the Ubuntu machine. So what we're going to do is send this nmap, this SYN packet, over to that machine, and we see some red pop up, and let's explain this here. So we see how the TCP three-way handshake is supposed to work. SYN, SYN-ACK, and then an ACK. So if we come here, this is what it's going to look like. We send a SYN, we get a SYN-ACK, meaning that the server acknowledges our synchronization request, sends its own, and this is what's supposed to happen. We're going to send an acknowledgement back. But this is what we're doing. We didn't send anything back. Actually, what we did was just reset, and we got our information, and this is a half open. So this is a SYN attack with a half open. So we know that port 22 is open. We connected to it upstairs when we did it up in the top of the exercise. We also know that this is filtered, i.e. is going through a firewall, and we know HTTPS is open as well. We received the MAC address, but the beauty of this here is that we're able to see this in Wireshark. So we could filter out for port 22, we can see this in real time, and we can see if we have half open attacks on our network. And there's other commands that we could put into here. For example, we can look at the TCP SYN flag and bring in extras as well, but just wanted to show you how we can see this in real time if there was a SYN flood, not a SYN flood, but a stealth SYN attack. So let's go ahead and stop this and do some housekeeping here. I realize this is intermediate, and we are in the intermediate class, so it's important that we understand the basics of this, and the links are in the show notes below to how to set this up and set the stage before we get here. This is considered intermediate, borderline, advanced. So feel free to take your time to work up to this level. Okay, we'll do another thing as well. Let's go ahead and take a look at some port 80. So I'm going to do port 80 on this side here. And I'm going to actually start continue without saving. We're good with that. And I'm going to just start a new capture. And let's see what happens if we do a curl command. So I'm going to do a curl and see if we can see some real-time information if we're going to do curl activity. So let's say we wanted to clear, and let me just, in the spirit of being clear, here I am sitting on the Ubuntu machine. I know that because I'm going to do ifconfig, and this is my IP address, 172.16.1.102, and we know the router is sitting on 172.16.1.1. Okay, fantastic. I'm going to curl, which is command line URL, the router, to see if I can pull that index.html file from the router. I go ahead and pull it, and sure enough, I can see it all in Wireshark. I can see that traffic. What exactly am I seeing? We're starting off with the SYN request, the SYN-ACK, the three-way, the TCP three-way handshake, and we get the acknowledgement. This is fine, right? So I get to see that information. I get the GET request, and I can now follow this packet step by step and see that whole journey for that curl command. And we get all the acknowledgement, and then finally, when we're done, we get the fin packet, which is closing out and is finished with that conversation. So another good example of how powerful this can be. One more before we start to put it all together with another command, which is another PCAP file. So let's do an ARP spoofing. This is optional, but it's worth it to go through this process. So I'm going to get back to the command prompt, bring it up here. I'm going to clear the screen. And at this point, I'm just going to do a quick ARP. And I'm going to do the ARP end, but I just want to show you why we do that. So the ARP cache is going to be the IP to MAC address table. So that way, as we're coming through the OSI model, and we're getting from the IP down to the MAC address, we need to have a table, which is on the network. I know what the logical address is. It's 172.16.1, but I also need to know what the physical address, and this table is going to help us do that. So let me move over here so we can see this in real time. This ARP cache is showing the table. So this is the Ubuntu machine and its view of the ARP cache. In other words, this Ubuntu machine sees the Kali Linux sitting on 172.16.1.103, and it has a MAC address of 13.6e. It also sees the pfSense router sitting at 172.16.1.1, and it has an Ethernet address of 81EE. So let's see this without the resolution. So I'm going to do ARP -N. We can see it without the name resolution, and we're going to do an if config. Okay, great. So I'm going to once again do it with the ARP -N so you can see that, and we are on this computer, the Ubuntu, with this MAC address. And this is what our ARP cache looks like. So once again, I'll clear it and I'll send it to the ARP cache here. Perfect. Now let's go ahead and look at this from the Kali Linux side. Let's go ahead on the Kali Linux side and see how does it view the network. First, let's make this a little bit bigger. And hopefully you are following along. If not, that's the beauty of this. This is a recorded session, so you can backspace and you can download this. Go to the website, download the companion guide, and build this and play with this yourself so you can get comfortable with it. Okay, first I'm going to do an if config, and I see that this is me here at the 172.16.1.103, and this is my MAC address, which is 0800276 echo 136 echo. So this is aligned. Let's see what my ARP cache looks like. I'm going to do an ARP -N, and let's bring that up here so we can see that a little bit better. And it sees the router at sitting at 176.1 with the MAC address of 81EE, and also it sees the Ubuntu machine at sitting at 1.102, and it has 1 Charlie Alpha 9. So all of this is working nicely. It looks good. Let's go ahead and do an ARP spoof. So for starters, I'm going to run the ARP protocol. I'm going to stop and start a new capture. And I just want to see ARP. I want to see these tables being updated in real time. But now we're going to do an ARP attack. The ARP attack is going to be a spoof. In other words, I'm going to go to the Kali Linux, and I'm going to tell this network here that the router is not sitting at 172.16.1. The router is not sitting here, it's sitting here. In other words, I'm going to trick this Ubuntu machine. It thinks the gateway is sitting at this IP address. I'm going to fool it and have it think that the gateway is sitting at this address, this MAC address. How do I do that? I go to the ARP cache and I run the ARP spoof command. I go sudo, let's do that this way, sudo ARP spoof. So it's sudo because you need super user privileges. This is the interface that we're using. The target machine is the Ubuntu machine sitting at 102, and we're going to have it think that the gateway is sitting on our Ubuntu machine. So let's go ahead and do that. We're going to be prompted for the password, and now I'm broadcasting on this network that A9, the ARP reply, is sitting here. So let's go back and take a look at this here. So I'm saying this is where you can find a gateway. Sitting here on 1 Charlie Alpha 9, you can find it at 6E. What does this all mean? It means if I go here, notice the ARP cache before I refresh it. This Ubuntu machine thinks that the gateway is sitting at this Ethernet address. I'm going to do an ARP-N, and now it doesn't know. It's fooled. We have 2 MAC addresses on the network, duplicate MACs. As you know in class, MAC addresses are unique. If we have 2 duplicate MACs, if we have duplicate MACs for that matter, that means you're under some type of ARP spoofing attack. The beauty of that is that you can see all of it here in Wireshark. And that was the point of setting up this exercise, so you can see this is totally optional. I wanted to put it in here because of requests. It's a good way. This is more on the back end of intermediate, getting into an advanced, but we wanted to share that with you as well. Okay, so as soon as I stop this on the Ubuntu side, things will go back to normal. So I'm going to stop that. Let's do a Control D on this. Let's go here. Let's do Control Z, will do it as well too. I'm going to clear. So we're looking fine here. We have stopped. It takes a while for the packets to stop here. We go back to Ubuntu, and now I'm going to run the N, and everything is now back to normal. We are back to how we first started. The Kali Linux is sitting on 6E. pfSense is sitting on Echo Echo. We have reversed this process here, and we're back to normal. Yeah, I know, this is really good stuff. Okay, so let's put this all together. I know this is an extensive course, but Wireshark is an extensive topic. There's a whole course on it, and we'll talk about it when we get to the bottom. So let's put it all together, and let's open a file that I have already on my machine. So first I'm going to stop this capture. I'm going to open a file that we can find in the companion guide called Telnet Cooked PCAP. I'm going to continue without saving, and I'm going to get rid of this portion here, and we have a file that I could bring here that was created back in 1999, but this is for important information for us here. It's a Telnet file. So we have a file, we look at the packet list pane, so we can see we have all the packets here. It says we have a total of 92 packets. I'm going to go to the last packet, and it's true, I do have 92 packets. I can go ahead and look at all the different types of protocols that we have. So I'm sorting by protocol. We have TCP, we have Telnet traffic, and it's probably sitting on port 23. If I wasn't sure, I can go to our appendix of the work group, and we see that Telnet is port number 23, TCP, and the service name is Telnet. So everything is aligned. It looks good. Let's go take a look at the statistics protocol hierarchy here. So we go statistics protocol hierarchy, and we see the 92 packets, 46 of them or 50% are Telnet related, and there's a malformed packet. That's just good information to share working with teams or for ourselves. Okay, let's apply a basic filter. We know this is all Telnet traffic, so let's do a TCP port 23. This is going to filter all the port, and if we go in, we see the initial request here, which is the SYN/ACK. Great, the TCP three-way handshake was successful. This is the timestamp. It gives us a good feel for that. We can also sort by the destination of the IPs. So we can go here and sort by source IP to destination IP to see which way the traffic was going, and it gives us a detailed packets to 811. Obviously it's skipping because it's showing the traffic flow from .01 to .02. Okay, let's go ahead and take a look at the TCP stream. So we're going to right click on a Telnet packet. We're going to follow the TCP stream, and unlike SSH, we're able to see the plain text, which is why we don't recommend using Telnet, because it's all in the clear, and Wireshark allows you to see that. So we're analyzing the Telnet is unencrypted. So we can see the login. This is the user that logged in. This is the password that they used. We have the time, and we also see the commands that they ran on the session. So they ran ping, they pinged Yahoo, they got some replies from here. They also did an ls in this directory. So they got a list, and then they also did an ls -a, and then they exited out of the session. All of this in the clear because we were able to right click on the Telnet packet, and we followed the whole stream, which is the collection of packets that created all of this information. The illustration here that we're trying to impress upon is, one, do not use Telnet. Most services do not have them available anyway. We want you to use SSH, which you saw in the beginning of this tutorial was secure and encrypted. And you see that you have complete visibility here. So since Telnet is encrypted, we couldn't see it. We saw all the commands. We also can see in the packet details pane, as we saw before, the frame coming through the OSI model. So if I bring this on top, we can go ahead and see it come in through the physical layer, layer 2, layer 3, layer 4. This is a layer 7. It's an application, and we can expand all of these options. So this is it coming through the wire, coming right up through the OSI model, which you can track the packet and find out its journey and information along the journey. For example, if I'm at the MAC layer 2 area, I can pull the MAC address here as well, and I can get the information that we need here. Okay, great. So let's go ahead, and if we need to do any work here, we can also do file, and we do packet dissections, and we could save this as plain text. I'm going to save it here. I'll overwrite this one, that's fine. And if we need to, we can go right into our folders, systems. Let's see if it's downloads. We just had a telnet extract. And is this if we need to share it with someone or need to format this into a different table. But we just extracted that details pane into a text file and create a report. Okay, a little bit more. Last but not least, before we go through a few things, file export objects. If there were file transmissions in here, like a PDF or a text file, we can actually snag that file from the packet list as well. We can go to File, Export Objects, and let's just go ahead and just take HTTP, and it would show up here. There was a file here. Okay, let's do a little bit more housekeeping. And quick, we saw this in the beginning, so it's probably worth closing out at this. Statistics and conversations. These are the conversations that were happening in this packet stream. A is .01, B is .02. We can see the IPv4 traffic. We can see the MAC address traffic. Of course, we can break it down by the protocol. We know it's on TCP, and we can see the flows, the directions of A to B, A to B, B to A, who was speaking the most, in what direction. We can also plot this on a graph, IO graph, and I'll just pick a regular time graph so you could see the duration, so it gives us the time. And this is helpful if we need to report out as well. And then last but not least, let's go to statistics and endpoints to give us an idea of the different devices and the packets that were happening here. So this is advanced analysis. Just wanted to share it so that way we have this for the video, because this is somewhat comprehensive in terms of all the information that we're sharing. So obviously this is the tip of the iceberg. Wireshark is a big platform in the sense of its capabilities and what it can do. If you want to learn more, you can go to wireshark.org. You can find that here, and you can download it right onto your host computer. Remember, keep in mind of all the legal issues in your area. If you can download them, if you are, make sure you have permission to run it, or run it on your own networks in an educational environment. And also, if you want to get sample PCAP files, this file that I got, the telnet cook, was actually a sample capture file that'll give you traffic that's a little bit more robust. If you can't create the same experience in your lab environment, you can go to sample captures and download the PCAP files, all different types. So this is IPv4 fragmented echo requests. This is a TFTP, obsolete packets, and this is just unsorted. And there's a whole list of packet files that you can use to get used to working with Wireshark. Last, remember, when using Wireshark or any network tool analysis, it's essential to always adhere to ethical and legal standards. We talked about it at the beginning of class. You want to make sure that you have the right permissions. I'm going to just go ahead and close out here and also close out this session. I think this was a little bit on the longer side because it's a comprehensive topic. But if you'd like to learn more, there are different tutorials and different options on wireshark.org, and you can go ahead and download, as I mentioned, or more specifically, there's documentation. And the documentation are similar to this. There are YouTube videos, Wireshark training, you do a TCP/IP deep dive, and there's additional topics on this. But I just wanted to introduce it to you in this course here because at a high level, we need to know what does Wireshark do and some of its capabilities. And as you prepare for your certification exams, it's helpful to know these topics from a higher themed perspective. So I really sincerely hope you enjoyed this session. I enjoyed preparing it and delivering it, and we'll continue with our journey. I'll see you at the next lesson.